So this video we're going to be talking about patterns and inductive reasoning and counterexamples. So when we're looking at patterns, we can make some sort of thing called an inductive reasoning. So it's when we observe a pattern, so when we're looking at a pattern and we're making a guess based on the pattern. So we're trying to make a logical guess based on the pattern. So here's an example. If we have -1, 2, 5, 8, we notice that each time we are adding 3 to it. Okay, so our next two answers then will be 11 and 14 because we have to add 3 onto 8 and add 3 onto 11 to get 14. The next one here, we got A, B, D, E, G, H. So it looks like we're skipping something. Okay, we're skipping every third letter. So that means our next one is going to be J and K because we need to skip the third letter. Our next example, it looks like we got 3 sides, 4 sides, 5 sides. So the next two are probably going to be a 6-sided figure and a 7-sided figure. Okay, what conjecture can you make about the sum of the first 30 even numbers? Okay, so our first, this is telling me my term, so my first number, my second number, my third number, my fourth number. So if we take 2, and then it says, we're talking about the sum, so that means we're adding. So then the next one is 2 plus 4. We add another even number on top of it, so 2 plus 4 plus 6 to get 12, and then we just keep adding on top of it. So you can see that each time we're taking that first number and we're going to be multiplying it. So the term is 1 times 2, and then the second term is going to be 2 times 3, and you're just adding on top of it. So each sum is the product of the number of terms and the next number. So we're trying to make a guess as to what's going on from one step to the next step. So the sum of the first 30 even numbers would be 30 times 31, which is 930. Counterexample, an example that shows a conjecture is false. So we're countering our original example, so we're trying to show why it's false. So all prime numbers are odd. A counterexample, 2. 2 is a prime number, okay, because it can't have anything divided out of it, but it is also even. The sum of two integers is always positive, okay? If we do -4 plus 1, -4 is an integer and so is 1, but if we add them we get -3. Okay, a counterexample is proving whatever our example is here, we're proving it wrong. Finding a function rule. So in this first example, we can see that we're adding 3 each time. Okay, this is our coefficient, so it is our main number. So we know it will be 3n plus something to get to the next problem. So if we plug in the values 3 times 1 plus c, we can solve it and set it equal to what our value is, which is 1. So we got c equals -2 when we solve it. So our function rule then is 3n minus 2. And it should work for every single value that you plug in here. So our next one, our function rule is going to be 5x plus 6 because 5 is our coefficient, it's what's being added on each time. And then if we plug it in and solve it, we can see that we keep moving up. So that's our function rule.